Okay, welcome to our lesson on consecutive integer and age problems. We're going to do a couple of the problems that you have in your notes, so make sure you're following along. We've already learned about consecutive integers actually, but just to remind you, a consecutive integer is positive or negative, so they could be positive or negative. Positive or negative whole numbers, because integers are positive or negative whole numbers. Whole numbers are their opposites, so whole numbers in a row. So the first part, positive or negative whole numbers, that's what an integer is. But the whole in a row part, that's what consecutive means. Okay, number one, write and solve an equation to find the sum of three consecutive integers with the sum of 48. Well, I'm going to go ahead and call my most mysterious integer x. That's going to be my first integer. Okay, now my next integer is going to be in a row. It's going to be the next number, so it's x plus 1. And you've already learned this with me before, but we're just kind of briefly reviewing this. And then if there's three integers in a row, the next one is going to be x plus 2, because let's say the numbers were 5, 6, and 7. 7 is 2 away from 5. Or let's say the numbers were 10, 11, and 12. 12 is 2 away from 10. So my third integer is going to be 2 away. So that's why it's plus 2. Now, I want to put them as a sum. So x plus 2, which was, excuse me there, x plus 1, because of that one, plus this one, x plus 2, is going to equal my total, which is 48. So when I combine my like terms, the x's, and then combine the numbers with each other, I get 3x plus 3 equals 48. I'm going to subtract 3. And I get 3x equals 45. When I divide by 3, I'm going to show my work up here, x equals 15. Now that's not the final answer because it's asking what the integers are. So I need to know that I'm talking about 15, 16, and 17. Now if you add 15 plus 16 plus 17, you find out it is actually 48. Okay, next part. Write and solve an equation to find three consecutive even integers. Now, with even or with odd, and that's where people get confused. Now, by the way, we're on the back side. We're on number 4. With even or with odd, we're going to start with x being the first integer. But when we talk about evens, they're 2 away from each other. When we talk about odds, they're 2 away from each other. For example, 2, 4, and 6, or 10, 12, and 14. Or if we were talking about odds, because one of these questions is going to ask you about odd, they are still 2 away, 21, 23, 25, things like that. So it's going to be x plus 2 for the second integer, and then x plus 4 for the third integer. Okay? Sorry, I'm having trouble writing right now. We're going to have to find their sum. So x plus 2 plus x plus 4 is going to equal negative 126. Now I know I'm expecting a negative answer here if I don't get one, or if I get a fraction or decimal. I know I did something wrong. Okay, I'm going to combine my like terms. So 3x plus 6 equals negative 126. And now what I'm going to do is I'm going to subtract 6 from both sides. Now remember, when you're subtracting and there's negatives, we want to do like a leave change opposite. So this is really like plus negative 6. So it's negative 132. I divide by 3, and I get my final answer, which is negative 44. Now, the next number, plus 2, would be negative 42. I'm getting closer to 0, and then negative 40. Now, if you add negative 44, negative 42, and negative 40, you will get negative 126. So you know you got the right answer. Okay. Problem number 5. This is also on the back side. Mrs. Wang is 23 years older than her daughter. In 5 years, their ages will sum to 63. How old are they now? Well, there's a couple of ways that you could do this, but the first thing we need to do is define a bunch of variables, and I'm going to type actually because I'm having so much trouble writing. I think it will be neater if I type for now. So I'm going to say that x equals. Now, I know something about Mrs. Wang. I don't know anything about the daughter. And we always want our most mysterious variable to be our x. So x is going to be the daughter's current age. Okay. And if Mrs. Wang is 23 years older, then x plus 23 is going to be Mrs. Wang's current age. Now, sometimes people get confused and they want to say like X and Y. We don't know at this point in time how to do that. We know just one variable. In 8th grade, you'll learn two, but for now, we need to define one variable in terms of another. So if I know the daughter is X and I know Mrs. Wang is 23 years older, I'm going to have to call her X plus 23. Now, something else that some people like to define is because it talks about in 5 years, the daughter is going to be X plus 5. So daughter in 5 years, because everyone gets 5 years older. Now, Mrs. Wang in 5 years is this, because she also gets older. Okay, so those are our variables. Now it says in 5 years their ages are going to sum to 63. That means I need to use, oh, sorry about that. That means I need to use this and this. The daughter's age in 5 years, Mrs. W's age in 5 years, they're going to sum to 63. So what I'm going to have is X plus 5 plus X plus 23 plus 5. And that, in the 5 years, is going to equal 63. So we defined our original variables, we defined our variables in 5 years, and now we're saying in 5 years, if I add her age plus her mom's age, it's going to be 63. So what I'm going to do next is combine my like terms. 2x plus 33 equals 63. And then I have to subtract 33 from both sides, and I get x equals 30. And you divide and you get x equals 15. Now that's just the daughter. We want to know both of them. Now the daughter was X, so that's her current age. So her current age is 15, and then we have to add 23 to get to the mom. So the mom is 38. Now let's check this. In 5 years, the daughter will be 20, and in 5 years, the mom will be 43. And so if we add them, it does equal 63. So that's right. Okay, and for the final question, what I'm going to do for you is just set it up for you, and then you're going to do the rest on your own, and you'll finish off the worksheet as well. So it says Melissa is 24 years younger than Joyce. In 2 years, Joyce will be 3 times as old as Melissa will be then. How old are they now? The very first thing I need to do is set up all of my variables. So there's a lot of defining here, and you're going to be doing this each time that you do an age problem or a consecutive integer problem. We have to tell what the variables mean. So x equals, now it says Melissa is blah, blah, blah. I know something about Melissa, so I'm going to pick my more mysterious person. This is going to be Joyce's current age. So Melissa is 24 years younger. So I'm going to go ahead and say that x minus 24 is Melissa. She's the younger one. So Melissa's current age is right there. Now, in 2 years, Joyce will be 3 times as old as Melissa will be then. So basically, in 3 years, in 2 years, I need to define as well. So this is Joyce in 2 years, and Melissa is this in 2 years. Melissa in 2 years. Now, that's a whole lot of mumble jumble right there. I see negative 24 plus 2, so I'm going to actually reduce that. I'm going to simplify it. That's her age in 2 years. If you want to keep it as minus 24 plus 2, that's fine, but to me that's a little too complicated. Okay, so now it says in 2 years, so we're using these. In 2 years, Joyce will be 3 times as old as Melissa. Now remember, Joyce is the old one, Melissa's the young one. So to make them equal ages, we're going to have to multiply Melissa's age by 3. So in 2 years, this person, Joyce, x plus 2, however old she is, will be the same as Melissa times 3. She'll be 3 times as old as Melissa. So we need to do 3 times, and I need to use a quantity symbol because Melissa is that entire chunk. Okay, I want you to finish off the problem and solve it, and then finish off the worksheet as well. Thanks for watching. Have a good day.